Okay, we're going to go ahead and get started with this morning's lecture. Thank you everyone for joining us today. My name is Isaac and I'll be the lead instructor for today's lecture. And the topic today is going to be database basics in NoSQL. Okay, so a few things to mention before we get started today is we aren't going to be taking any questions during the lecture. So if you do have those come up along the way, feel free just to jot those down and then send me either an email or Slack message afterwards, at which time I will follow up with you. Another thing to mention is we are recording this lecture. So after we're done here, we're going to post it on the Slack channel for you to review at a later time. Okay, so as I mentioned a minute ago, we are going to be discussing NoSQL databases today. And in particular, we're going to be discussing a NoSQL database called MongoDB. Okay, so before we dive into MongoDB, let's go ahead and explore what is a NoSQL database. Okay, and a NoSQL database is a database that allows the insertion of data without a predefined schema. So if you're coming from a SQL background or familiar with SQL databases, you know that each table of data must have a predefined structure. So this is the exact opposite with NoSQL is the fact you can just throw data into your database and it will adapt to the structure you give it. Okay. So just like any new technology that we're using, we should always start by looking at the documentation. So the documentation for MongoDB can be found at mongodb.com. Okay, and then from here we can just look at the docs, and they're gonna give us all their different solutions. Which if we just want the server plain database, we could go here, and it's going to give us all the ins and outs of how to use MongoDB. Okay, so this is great for getting started, but as well, you should also use this for debugging when you're trying to figure out, how to get something to work. Okay, so now let's go ahead and talk about database solutions and what kind of solutions we can have. Okay, so there is what's referred to as an in-house solution, which is just a database that's hosted on a server, which is actually kept in the physical location in which your development team works. So that's one solution, and it is used. However, it's considered a little dangerous in the fact because it is one physical location, and if everything got burnt in a fire, there goes all your data. So these days, a lot of people prefer to use what's called a cloud provider. Okay. So MongoDB, the database, we can use on our local server, or we can also use in a cloud. Okay, and with a cloud provider, we have all our data backed up, and we don't have to worry about one physical location being responsible for all of it. Okay, so that's what we're going to use today. We're going to use a cloud provider, and the cloud provider is called MLab. Okay, so if you go to mlab.com, go ahead and sign up for a free account. And once you log in, you're going to get pulled up to this menu here. And, this is just our base dashboard for, navigating, the different aspects of our database. Okay. So from here, let's go ahead and create a MongoDB database. Okay. And how we can do this is we can either create a regular deployment or a private. And at this time, we're not going to get into private deployments. All you need to worry about is the regular deployment. Okay, so we're going to go ahead and we'll say create new. And from here, it's going to ask us our cloud provider. Okay, so we're going to keep it on the default AWS. And then I'm going to choose Sandbox because this is the free version. Okay, and then we'll go ahead and continue. From here, we need to search the region nearest us. So I'm going to select this region and continue. From here, I need to give the database a name. So I'll just call it Coder Camps DB. Okay, and then I just need to review everything. If it all adds up, I'll go ahead and submit my order. And it's going to generate that database for us. Okay. So now we have a database. We need to discuss the security of this database because, as you know, oftentimes sensitive information goes into a database, such as passwords, sometimes social security numbers, etc. So, to make sure that not anyone who has access to our MLab account, it can just authenticate, right? We want to set up a database user, okay? So we only have specific people who can authenticate this database. So how we can do this is go inside your database and select users and go ahead and click on add a database user. Okay. And from here, let's go ahead and give it just a name. Doesn't matter. I'll call mine Isaac. Then I'll give a non-sensitive password like 123, just to make it easy for everyone. Then we'll go ahead and create. And as we can see now, we have this database user. So we have a way to authenticate ourselves and connect to this database using the Mongo shell. And from there, using the Mongo shell, we can perform various different operations for our database. Okay. Now we have the database set up. We can connect to it on our local machine using a command line. Okay. So when you install MongoDB, it comes with the Mongo shell. And so from here, to activate the Mongo shell, we just need to paste in our connection string. Okay. So how we do this is we see it lets us know, you can connect using this if you're using the shell. So we're just going to copy this and let's go ahead and let's paste it in like so. And what I'm going to do is I'm just going to back up to the point of my user because these are just placeholders, right? So what I want to do is I want to erase this placeholder and put my actual database username. And then remember how I said my password was 123. So I'm going to get rid of this placeholder password and put 123. Okay. And now when I hit enter, it's going to make a connection to that database. Okay. So now I can interact with it from my command line here. Okay. So my database is in the cloud, my machine's, somewhere, and now those two are communicating. Okay. So now before we start throwing data into our database and, manipulating all that good stuff, let's go ahead and talk about the breakdown, the structure of a NoSQL database. Okay. And to best explore this, let's go and look in our MLab account. Okay, let's click on collections. Okay, so as a whole, your database is going to be made up of different categories of data. Okay, so you can think of some program like Facebook where they've got user data, but then they've also got post data, right? So they're and everything works together, but they're definitely separate in their own regard. Okay, and so this is what a collection is in your database. Okay, you should have a different collection for every different category of data. Otherwise, you would just throw all the data into your database, and then it would be madness trying to sort out data sets. Okay, so we have collections to help us segment those. So within collections, we have what's called a document. Okay, and a document is just a record. Okay, it's an entry in our database, such as if we were to create a user, the user would be comprised of one document. Okay, and on that document, it's represented in JSON format. Okay, so we've got fields, and values. Okay, just like a regular object, and from there, the document is referred to as fields. Okay, so username, age, weight, gender. Okay, those would be fields on the document. Okay, so you can think of them as maybe characteristics of that piece of data. Okay, and that's the breakdown. Okay, we've got collections and documents and fields. So let's go ahead and let's set up our first collection here. Let's go ahead and let's call this our cars collection. Okay. All right. So now we've set up our cars collection. we can now start inserting data and doing various different operations. So let's go ahead and head back to our command line. And from here, we can go ahead and start inserting data using a special set of commands, okay? And all these commands can be found in MongoDB's documentation, okay? So just know that you can always reference there if you forget what we go over today. But the basic syntax is we just need to start off by saying DB, then collection, okay? And then the collection needs to be the name of the collection we're targeting, which in this case is .cars, okay? And then what we need to do is we need to throw in the command we want to run, which in this case would be insert, okay? And what we're going to do is we are going to insert an object, okay? So this object, we could give it, you know, different values. Let's give it a type in year, okay? So let's say it has a type, and we will make this, whoops, here we go, Tesla, okay? And then when we hit enter, oh, I almost forgot the year. Let's make it 2017. Why not? Okay. And then when we hit enter, you can see it says acknowledge true. And then we get this inserted ID. Okay. And what that is a unique feature of MongoDB is every time that you create a document, it automatically creates a unique identifier for that document. Okay. Because in the event that we have documents with similar fields, we need some sort of identifier to separate those. So for example, if I want to look up all the people on Facebook with the name of John, you know, I'm going to get a lot of people back. But maybe if I have an ID for a specific John, I can just get one record back, okay? And so this is typically how databases work as a whole, right? They use IDs to separate records. So if we go into our MLab account and we hit refresh, we can see now we have, well, looks like we created a new collection here. Why did it do that? Oh, yeah. Looks like I put an extra word there, folks. So what I'm going to do is it created a new collection because I accidentally put collection.cars. And so, yeah, watch what will happen. So we'll delete this, okay? So we delete our old collection. Now we have our regular collection there. And what we're going to do is we just need to say db.cars. I don't actually need to say collection. And then I say .insert one, and then let's throw in a type of Tesla and a year of 2017. Okay, that's better. All right, so now when we go back, we can refresh, and we see now that instead of getting the multiple collections, it just targeted the cars collection, and it added the document with the type and year, just as we specified. And then it added this unique identifier, okay? So it'll never duplicate this ID, okay? So we know now that we have a way of separating and targeting this individual record if needed, okay? So now, just to get the swing of it, let's go ahead and insert a couple more cars into this collection, okay? So we can say db.cars.insert one. Let's go with Mercedes, type Mercedes. Okay, let's make the year 2000. Okay, just like we did with our Tesla, we'll hit enter, gets inserted. Let's refresh our browser just to make sure everything went good in MLab. So we can see we're adding more documents to our database, okay? And this is all within the cars collection. So let's add one more car just for good luck. db.cars.insert one. Then let's go ahead and throw in a type let's make it BMW. And then let's go ahead and make the year 2006. Okay. So now we've got, 3 different cars in our database, okay? Got the BMW, Mercedes, and Tesla. And as you can see, I'm sending data from my machine's desktop to the cloud provider's database, okay? So from here, we've just learned to do what's called creating a document, okay? And in reference to databases, there's a common operation referred to as CRUD, okay? And CRUD stands for create, read, update, and delete. So we've just learned how to create new documents. So let's go ahead and learn how we can read those documents. What we can do is we can set up different filters and conditions, or we can retrieve all of them. Okay, so this is where we switch to the word looking or searching, and we start using the word query. Okay, so anytime you ask for something from your database, you're running a query. Okay, so let's go ahead and find out the different kinds of queries we can run with MongoDB. Okay, so first off, let's go ahead and let's explore how we can find just all documents in a collection, okay? In this one, all we have to say is db.cars.find, and then we just pass in an empty object. And from here, it finds all the documents. As we can see, they're returned, just as we expect them to be, okay? So that's how you can get all cars, okay? So let's talk about how you can get cars using equivalence, okay? So let's say we want to get all cars with the name or type of Tesla. So how we can do this is we say db.cars.find, okay? And then we're going to pass in bling eq, colon. Then we're going to pass in the condition, okay? So we're going to say with a type equal to Tesla. And we'll go ahead and we will close that off. Okay, so from here, we can go ahead and execute this. Looks like I'm missing, what am I missing here? Oh, I'm mixing up my type and my syntax. Sorry, folks. Copy hasn't kicked in yet. So we've got to switch those around. So we're going to say db.find, and then what we've got to do is we pass in the what we're trying to find first. So the field is the type, okay, and then we pass in the operator, okay. So in our case, the operator is bling eq, and then the value is Tesla. Okay. Yeah, it looks like I keep missing. Oh, because I'm not passing in. Yeah, I'm not passing in an object as my query. So yeah, sorry. One more time. Let's do this. Find, and then I have to pass in an object which searches for the field of type, and then we use the equal operator to search for all documents with a type of Tesla. That's what it is. Okay, so from here, let's go ahead. Oh, you know what though? On type, I need to go ahead and add another bracket here. Okay, and then we'll say EQ, and then we'll pass in Tesla, and then we will go ahead and close that up. Okay, so now you can see when we execute this query, it only returns one document, okay? And that's a document whose type is equal to Tesla, okay? So this is, the equivalence operator, okay? So let's go ahead and let's, explore comparison operators, okay? So let's find all cars with a year greater than 2005. So we say db.cars.find. Then we're going to go ahead and pass in the year, okay? And then the operator is going to be GT, which is greater than. and then the value we'll pass in as 2005. Okay, and from here, when we hit enter, we can see that the only cars or documents that return to us are all the documents with the year above 2005. We can see this Mercedes here with the year 2000 was ignored, and it only retrieved these documents. Okay, so as you can see, these operators allow us to add fine-grained control to our queries. So let's explore a couple more. Let's go ahead and explore less than. Okay, so let's do all the cars less than 2005. Okay, so we'll say db.cars.find, and then we're going to search for the year field. And from here, we're going to use the bling less than operator, and we're going to pass in 2005. Okay, and we can see now Mercedes is the only document that's returned to us because it's the only document with a year less than 2005. Okay, so now let's go ahead and let's talk about how we can combine queries by using logical operators. Okay, so let's talk about the AND operator first. So sometimes we want to combine multiple conditions into one query, and how we can accomplish this is using the AND operator. So let's go ahead and let's find all cars with the year greater than 2005 and less than 2010. Okay, so how we're going to do this is let's go ahead and let's say db.cars.find, and then we'll pass in bling and. Okay, and it's going to take in an array, and the array is going to be our conditions. Okay, so this first condition here, I'm going to say we want to find with a year, okay, that is bling greater than the year 2005. Okay. And so let's go ahead and close this off here. And then we'll pass in another operand, and this will look for the less than. Okay, and we'll put 2010 here. Close that off, and then we will close our array. And finally, when we execute this, it should find all the cars with a year greater than 2005 and less than 2010. Okay, and success. As you can see, the only document that we got back was the BMW because its year's 2006. All right, so by now I'm sure you're starting to see the usefulness and the power of queries and how they apply to everyday web applications. Okay, so let's go ahead and let's explore the OR operator. Okay, because sometimes we want to look up one or another thing. So for example, maybe a customer goes to a car lot and we have a special program that tells our customer what cars we have in our inventory. Okay, but let's say they're open to a couple different options. They, are cool with, a couple. So to be able to search for both of those at once instead of having to run two queries, we can use the OR operator and just combine those. Okay. So let's go ahead and to combine them, let's go ahead and find all cars that are Tesla or BMW. Okay. So what I'm going to do is I'm going to say db.cars.find. We'll pass in bling or. We'll pass in an array. And just like and, this takes in, our expressions. Okay, and from here, what I'm going to say is I'm going to pass in type of Tesla. Okay, or we're going to search for as well type of BMW. Okay, so maybe, the customer doesn't care which one of these they get. So we just want to search our database for either one. Okay, so we hit enter here, And we can see that the only cars or documents it returned was, the types matching Tesla and BMW, and it ignored all of our other records. Okay. So now let's go ahead and let's talk about how we can find documents just by like existence. Okay. So maybe we want to find if a certain document exists. So let's go ahead and explore this. Okay. So we can say db.cars.find. Okay. And let's pass in color. And then we'll use the bling exists. And we'll pass in true. Okay. Okay. Now, as you can see, we didn't get anything from that. Okay. So I'm gonna go ahead and restart my connection here. So that's because we didn't have, or let's see. No, looks like I'm gonna have to type my connection string again. 1 second, folks. I shorted out my old one because it couldn't find any fields in the document that match a color. It just shorted out on us. Okay, so what we're gonna do is let's go to our database again, and from here I'm just gonna copy my string and paste it in, and then I'll just switch out my database user again. No big deal. Just take 1 second here. We'll say Isaac, and then for the password, we will do the ultra secure 123. Oh, okay. It looks like it didn't actually disconnect. It looks like I'm still connected. So good. We are clear to move forward then. Okay. So now we've explored a good amount of queries. Let's go ahead and let's talk about projections. Okay. And projections are a way that we can search for just specific fields on our data instead of retrieving the whole document itself. Because as we've seen so far, it just returns the whole document anytime something matches our query. And sometimes, especially when you have a larger application, which is receiving multiple queries to the database on a regular basis, it's a good idea to only search for what you need and not just like the whole thing. Okay, so we can do this and accomplish this by setting up projection. Okay, so let's go ahead and let's say db.cars.find. Okay, then we're going to pass in an empty field here. Okay, and then we're going to say type 1. Okay, and 1 is true, and if we pass in 0, it would equivalent to false. Okay, so as you can see now, instead of receiving the type, year, and ID, we're only receiving the type. Okay, and as well, by default, we do receive the ID, which if you wanted, you can ignore. So let's explore that just to get a real handle on projections. Okay. So we could, if we wanted to only retrieve the type alone and ignore the ID, we just have to pass in 0 for this, okay? So what we're going to do is we're going to say db.cars.find, and then we're going to pass in type 1, and then underscore ID will pass in a 0, and that's false, meaning we don't want it to return this field. We only want it to return this field, okay? So from here, you can see now we're getting an even faster search because we're only retrieving the type off these documents and not every single field, okay? Next, let's go ahead. We've explored how we can create data, how we can read it. So let's talk about how we can update data, okay? Also known as editing it. So to do this, usually, we're going to use something to target the data, okay? So in our case, let's go ahead and let's update our Tesla from the year 2017 to the 2018, okay? So how we can accomplish this is, let's go ahead and say db.cars.update1, okay? And then for this first argument, we just need to pass in which cars we're updating, okay? So in this case, we'll pass in type, and type is going to be equal to Tesla, okay? And so for the second argument here, we've got to use the bling set operator to set the new values, okay? So we're going to say bling set, okay? Or forgot need here we go. Bling set, okay, and then we'll pass in year. We'll say it's 2018 now. Okay. Then last, we have to put this upsert statement. Basically, we'll replace the whole object. Okay, it'll just keep the ID. From here, let's go ahead and close this off, and we'll close this off as well. And I think we got one more here, and I think we should be good. So let's try it, okay? Oh, I knew I was gonna miss something. Some sort of parenthesis I'm missing. Let's see here. Okay, so I'm just gonna copy this. I don't really wanna type it all out again. Let's see here. Well, I'm starting with my, okay. Yeah, I think, here we go. This is what I did wrong, folks. I was supposed to put a bracket, and I put a parentheses. There we go. Okay, so now we should be able to add another bracket here and execute. What's going on? Now I'm missing one. So, oh, because, yeah, I have to account for the beginning one too. Yeah, these queries can be a little tricky sometimes. So let's go ahead and add one more parentheses. And what is going on? Missing after main arguments. Okay, now let's just try this. Okay, db.cars.update1. Okay, so let's go ahead and pass in Tesla as the type. Okay. And from here, let's go ahead and pass in the bling set operand, and we'll pass in the year. And for the value, we'll make it 2018. Close that off, and then we'll throw in an upsert statement here. And this upsert statement should evaluate to true. And then we will close off our bling set statement. And finally, parentheses. Okay. Looks like I'm still missing. It says I'm missing another parentheses. Oh my goodness. Let's see what's going on here. Let's try this again, folks. My eyes aren't working. There we go. Yeah, it's always one bracket off or something like that. But this is the correct setup right here. Okay, so as you can see, we are just targeting the document with the type of Tesla, and we're setting the year to 2018. We're replacing the whole document. Okay, and as you can see now, it lets us know, hey, one was modified and everything went through successfully. So now, if we look at our documents, okay, let's go into our cars. We can see that Tesla is 2018 instead of 2017 like we originally inserted it. Okay, so this is how you can update data inside your database. Okay, so let's go ahead and talk about deleting data. Okay, and so all we have to say is db.cars.delete1, and then maybe I want to delete my BMWs. Okay, maybe I don't want those anymore. So I could say type and pass in BMW as the filter. Okay, we hit enter here. We can see it lets us know everything was successful. So from here, if we go ahead and we navigate back to MLab, we can refresh. We can see now we no longer have the BMW inside of our collection. Okay. So now you've seen how you can perform full CRUD operations, creating, reading, updating, and deleting data. Okay. So let's go ahead now and let's talk about how you can increase the speed of your queries even more by a concept called an index. Okay. And in MongoDB, an index is just a copied version of a document, which is set aside and can be accessed quicker than a non-indexed item. Okay, so by default, IDs, for example, are automatically indexed by MongoDB. Okay, so to really understand this, if we go to our MLab, we can see that inside here we've got indexes, and we can see that the only index right now we have is for the ID field. And that's because this is a very commonly queried field. So that brings me to my next point, is when to index a specific field. Okay, and it's going to be on fields that you find yourself querying often. Stuff like I need the username, or common data requests you want to set up an index for, and that way you can access that even quicker and improve the performance of your program. Okay, so let's go ahead and let's just create a new index. Okay, and let's say we'll create an index on our specific values for our cars. Okay, so we'll say db dot cars dot create index. Okay, so first thing we have to do is we just have to pass in the filter. Okay, so what fields do we want to be indexed, and then we pass in a 1 for true and a 0 for false. So the type, we know we queried that often, so let's pass in 1, and the year, let's go and pass in 1 as well. Okay, so from here, when we hit enter, we can see that it lets us know that it created an index for us. And now when we search for type and year, it's going to have an ordered copy of that, and it's going to be able to directly query that ordered copy instead, resulting in a faster query. Okay, so now let's go ahead and let's talk about the concept of a one-to-many relationship. Okay, so to best understand a one-to-many relationship, let's go ahead and head over to yelp.com. Okay, so Yelp has a great way of demonstrating this when we enter values to find places. Okay, so for example, maybe I want to find restaurants, okay, near San Francisco. Okay, so what this is doing in the database, it's relating one place to many restaurants. Okay, so one city is related to many restaurants. Okay, so we can do similar operations inside of our own database by creating one document that has a relationship with many. Okay, so to explore this, let's go ahead and let's create a couple new collections. Okay, so we'll go to our database, and I'm going to add a categories and places collection. And that way we can kind of set up, the category is food, the place is, wherever. Okay, so from here I'm going to say add collection, and we'll go ahead and call this places, and it will add that for us. And from here, let's add the categories collection. Okay, so we'll say categories and create that as well. So from here, let's go ahead and create a couple different places. Okay, so I'm going to say db dot places dot insert. Okay, and then let's go ahead and give a name as well as that's it. Let's just give the category, the place and name. Okay, so we'll say name, and then I'll pass in Disneyland. Okay, and we will execute this operation. Okay, so we head back and we can see now inside we have one document in our places. So let's go ahead and create a couple more places, just like Yelp has a bunch of places. Let's make sure we do too. Okay, so the next place, let's go ahead and let's create maybe a different place. Let's make it same kind of category though. Maybe Universal Studios. It'd still be entertainment. Okay. And then we execute that. It went successfully. So now let's create a third place. Except this place, I'm actually going to make more of a food place. Oops. bb.places.insert. And then let's go ahead and give it a name of In-N-Out Burger. Okay. So yeah, we got a couple categories, or a couple entertainment places and one food place. Okay. So now let's go ahead and insert that. Verify our collection looks good. Okay. Perfect. So from here, let's go ahead and let's create our categories. Okay. And this is where we're going to create the one-to-many relationship. Okay. So I'm going to say db.categories.insert. Okay. Then what I'm going to do is I'll give the category name. Let's start with entertainment. And entertainment. Yep. And then let's go ahead, before we close this off, we'll go ahead and give it a field called places. And this places field is going to be full, of all the, specific places in question. Okay. So let's go ahead and let's pass in an object. Okay. And we'll say the name is Disneyland. Okay. And then, oh, you know what though? We need a collection of places. So let's have an array, and then the name of this first place will be Disneyland. Okay. And then the second place, we'll go ahead and pass in Universal Studios. Okay, so we'll close off this array, and then we will close off the command. Okay, so now let's go ahead and take a look at our categories collection. Okay, so we see in categories, we have one category now. And now entertainment has all the places which are associated with it. So let's go ahead and do the same thing for food. Okay, so we can say db.places.insert. Okay, the name, we'll make food category. And then the places for food, we'll go ahead and we'll pass in the In-N-Out Burger location. And that's really all we had to relate to that. And so we'll go ahead and close this off. Okay. So now what we've done is we've created one-to-many relationship between the category entertainment and all of this perspective places that are related to it and the category food. Okay, so now we have a very Yelp-like operation going on. So we can now run a simple query, one query to retrieve multiple facets of information. So let's go ahead and let's say db dot, let's do the categories collection, categories dot find, okay? Let's find all the categories with the name of entertainment, okay? And you can view this command right now, kind of like the user's input in the search box, right? So they hit enter. I want to find all places which are entertainment. Okay. So we go ahead and hit enter, and we can see now we have all the places that are associated with that. Okay. So we could easily access those and do what we want with them. Okay. And the same thing works for food. Okay. So we could say db dot categories dot find, and then we'll find all places with a category of food. Well, I don't know why it didn't return anything then. Let's check. We should have food. Oh, it looks like it never inserted our food document. So let's insert that just to make sure. So we'll say db dot categories dot insert, and then we'll go ahead and say name will be equal to food, and then the places associated with that. Let's go make an array, and we'll make the name of this first place in and out burger. Okay, so that closes up our array there, and okay, so yeah, now it was inserted successfully, and now we have a way to search for both our food and entertainment categories. Again, very similar to Yelp's operation that we just saw a minute ago. But that about wraps it up for today's lesson. So once again, thank you for coming today. We hope you enjoyed all the material that was presented. Again, we are posting this recording on the Slack channel afterwards, so keep an eye out for that. But besides that, have a great day and happy coding.